Okay, so let's do a little bit more terminology here. Tons of terminology. So hopefully we'll be familiar with all this terminology by the end of this. Coterminal angles are angles with the same initial side and same terminal arm. So let's say we have some sort of terminal arm in quadrant 2, and let's say that this angle is 160 degrees. So here we have theta equals 160 degrees. Now for this particular angle, oh my gosh, only part of the number came with me. Okay, so let's say that this angle is 160 degrees. We can have an angle that is coterminal to this angle if it starts on the same initial side, as all angles in standard position should, and then hits that same terminal arm. So here, this particular angle, let's call this theta 2. If this first angle in red is 160 degrees, then this second angle in blue, it should be negative 200, right? Because our reference angle here is 20 degrees. And so if we're going to negative 180 and then an additional 20 in that negative direction, we'll be at negative 200. Whoopsie daisies, we'll be at negative 200 degrees. So there we go. So there we go, and let's just call this theta 1. So these two angles are what we call coterminal because they end on the same terminal arm here. So they end on the same terminal arm. We can do another example showing you a different way that angles can be coterminal. So let's do one in quadrant 1 here. So if we do an angle in quadrant 1, let's make this roughly 60 degrees. There we go. So here we have a 60-degree angle. Now, we obviously could perform the same trick that we did last time to get another coterminal angle, right? We could just go in the reverse direction. But let's show you another way that we can have a coterminal angle. Another way we can have a coterminal angle is if we start at the same initial arm and then go through the terminal arm and do one more full revolution until we hit it again. So there, we'll call this theta 2. This is really just our original angle, 60 degrees, plus a full revolution of 360. So what should that be? 360 plus 60, that should be 420 degrees. There you go. So theta 1 and theta 2 are coterminal angles because they end on the same terminal arm. In fact, you could just keep doing this, right? You could just go to this terminal arm and then do another full revolution to get 420, and then do another full revolution again to get what is 420 plus another 360. That would be 780 if I'm not mistaken. So there you go. 780 degrees is an angle that is coterminal to 60 degrees, and it is also coterminal to 420 degrees. Again, we could, as I mentioned, perform the same trick where we instead go backwards. Or we could go backwards and then do another full backwards revolution, right? So we've got all of these different ways to get coterminal angles, and we can say in general that we can find an infinite number. We can find an infinite number of coterminal angles simply by adding or subtracting a full revolution or a full circle to some given angle. So we could say, let's say we have theta 1, which is some angle in standard position. We can find some angle coterminal to theta 1 if, so theta 2 is some angle coterminal to theta 1 if we just take theta 1 and add 360 degrees. Or we could add 360 degrees twice. Or we could add 360 degrees 3 times. Or we could add 360 degrees, excuse me, it's not erasing. What is happening here? Oh, we crashed. Okay, so we're back. So we could add 360 degrees twice. or we could add 360 degrees 3 times, or we could add it 4 times, or we could add it -1 times. How about that, right? So we could go all the way to this angle and then subtract 360 degrees from there. And really, if we do that, then we would just be at the corresponding negative angle of -300 degrees, right? So we could add negative revolutions as well. -2. We could add a negative revolution, a negative full revolution 3 times, and still find an angle that's coterminal. In general, you could add to some initial standard angle, you could add n full revolutions, where n is simply an integer. And this is essentially what this last paragraph says. So that's really coterminal angles in a nutshell. Here, theta 2 is going to be some angle that is coterminal to theta 1, as long as you take theta 1 and add 360 degrees n times, where n is either positive or negative, and an integer. So there you go. For unit circles, we won't talk too much about unit circles because we're going to talk a lot about them later. Unit circles are going to be very helpful for eventually generalizing sine and cosine functions and making graphs out of them. So we won't talk too much about unit circles yet, except to notice that if we have some angle if we have some initial angle in standard position and some terminal arm associated with that angle, that terminal arm would intersect the unit circle at some particular point, and that particular point would have x and y coordinates. And what are the properties of the unit circle that make it the unit circle? Really just that it has a radius of 1 unit. So for example, the terminal arm that intersects the unit circle along the negative x-axis, it would intersect it at -1 and 0 because the radius is really just a length of 1. So those would be the coordinates for that particular point. The 0 and -1 would be the coordinates for the point at which the terminal arm, a 270-degree terminal arm, would intersect the unit circle. Because it has a radius of 1, it would intersect it at 0 and -1. For the terminal arm that corresponds to a 90-degree rotation, that terminal arm would intersect the unit circle at 0 and 1 because, again, it has this radius of 1. And the same thing for if we have a 0-degree rotation, the terminal arm associated with that would intersect the unit circle at coordinates 1 and 0. So there's your unit circle primer. The really only special thing about the unit circle, at least in terms of the definition of the unit circle, is that it has a radius of 1. And we will be able to find any arbitrary point that any terminal arm, we will be able to find any arbitrary point where any terminal arm of any particular angle would intersect that unit circle, and it will actually be incredibly helpful. This really forms the basis of the more advanced upper-level high school trigonometry that we're going to be doing. So in the next video, as promised, finally, we're going to be looking at radians.